Hello, thanks for joining us today. So today we're going to share the second question on the quadratic equations. If you missed out the previous video on the sharing of how to complete a square and how do you sketch a graph, if you have a complete a square format in the equation, please go back to the previous one, right, to take a look at it. So for question 2 here, we need to first, before you sketch a graph, you want to factorize it first. Okay, so you don't want to leave it in the raw form like that. And the instructions here says that the coordinates that the graph has made with the axis have to be stated clearly, which means that in this question, the x-intercept is a must to have. All right. Previously, I shared that the two things that you must have for sketching of a graph is always the y-intercept as well as the turning point. Okay, but for today, take note that it will also include the x-intercepts as well because of the instructions being mentioned here. All right, so the first thing we'll do is we'll try and factorize out the common factor. So in this case, because for the only way we factorize here is not anything complex that you have to do cross method, right? You can just factorize out the common x from both terms, and you are left with 3x plus 2. So if you have the factorized form like that, then the first information that you can obtain out of it is going to be the x-intercept. Right? If you compare that to the previous video, I mentioned that if you have a complete the square method, the first thing that you can obtain is actually the turning point. Right? So the starting point of the first info that you will obtain is different in this case. So x-intercept is going to be the place where it cuts the x-axis. So when that happens, there is no value for y. That means the y is going to be 0 in that situation. Okay. So you sub in y equals to 0 into the equation, you have x times 3x plus 2. Okay, so these two times together to give you 0, which means that you will separate into either x is equal to 0 or 3x plus 2 equals to 0. Remember, for a quadratic graph for the x-intercepts, there are two solutions. So one of them is 0, the other one is negative 2 that. Okay, this is always the plan that we want to do before we sketch the graph, because we want to find out this planning stage regards to the important information so that we know roughly where to plot. Even though it's a sketch, you still want these things to be clear first, right? Then after that, you will be able to link to the turning point. Now, how would you get to the turning point if you start out with the finding the x-intercepts? Remember that the turning point is located in the exact middle between the two x-intercepts. So to find the turning point x value, the x for the coordinate, right, will basically be the mean of the two x-intercepts. Basically, if you add these two numbers together and you divide it by 2, you will get the x-coordinate for the turning point. Then after that, you will do y. Okay, so which means that after you find out what the x coordinate is, you will sub into the equation for you to find y. Right, it turns out that when x is negative 1/3, the y is also negative 1/3. Am I right? Yeah, do something wrong here. Let me check. Negative 1/3 times. Yeah, I got it. So which means the turning point coordinates is negative 1/3 as well as negative 1/3. All right, and then one more thing here is that we have to check for the coefficient of the x squared. This number here is a positive number, which means that it's going to affect the graph, right? The shape of the graph, remember I said it before. So this is a smiling curve because the x squared coefficient is positive, right? But if you have a negative x squared, then it's going to be a frown. Okay. So you have the x-intercept, the turning point, and then is there anything you miss out? Yeah, we haven't stated the y-intercepts as well, right? So let's do that. Now, for the y-intercept, as we mentioned in the previous video as well, the x is going to be 0, okay, which means that the place where it cuts the y-axis, there is no value for x. So when x is 0, you sub it in, that will be basically finding the y. And also a faster way to do that is you can check for the most raw form, the most expanded form in your quadratic equation here. This constant number is basically the y-intercept. So if there is no constant here, basically there is, if let's say it's a plus 5, right? This will mean that the y-intercept is 5. But here there is no number. This means that the y-intercept is at 0, which means that it will cut at the origin in the y-intercept. Okay. So just so happened that the x-intercept and the y-intercept is the same place because it cuts the origin. The other x-intercept is a negative number. So they must make sure that it hits these 2 points, right? And again, the shape of this should be a smile. So you should have you can begin to draw if this is what you prefer. If you find that it's very hard to draw the shape out after you label all the points, sometimes it might be a little bit challenging to hit all these points that you label. You can choose to draw the shape out after you know some of the details here. Then after that, you then label the turning point. Okay, this is what you can do as well. All right. So make sure that it is a smooth curve. And last but not least, please also label the equation name. All right, lastly, they also state that we have to state the equation of the line of symmetry. Again, this is going to be a vertical line, and for all vertical lines, you always cut through the x-axis. For all vertical lines, the equation is always going to be x equals to something. So in this case, it's x is equals to negative 1/3. All right. All right, see you for the next one.